Hello everybody, we are really happy to welcome you to this second NBS Breakfast. We hope that you grabbed your coffee with you and that you are ready to start your day. Just a quick reminder about what are the NBS Breakfasts. So these are 1-hour presentations, testimonials and exchanges organized by the European project Nature for Cities. And they were designed to discuss about specific subjects related to nature-based solutions. For your information, the replay of the first webinar is now available on our website, natureforcities.eu, on the blog section. You can also find there the links to register to the upcoming breakfasts. The thematic of today is on the diagnostic and assessment of NBS project with the following question. How can I choose the most suitable NBS regarding my local context? To introduce you to this question, we are welcoming today Marion Daniel from Plante&Cité. Then we will listen to Pyrène Larrey-Lassalle, PhD and Environmental Assessment Engineer at Nobatek in F4. She is going to explore for us a type of environmental assessment, the life cycle analysis. She is going to present us 2 case studies that have been assessed in the scope of the Nature for Cities project, a park and a green wall. And to conclude this breakfast, we will welcome Vera Enzi, CEO from GrünStattGrau, who is going to share with us the experience of the city of Vienna, who designed a strategy on heat islands at city scale, and some technical documentation to concretely support project owners. But let's not wait any longer and listen to Marion Daniel, who is going to introduce us to diagnostic and assessment of nature-based solution projects.
Thank you, Mathilde. So just to remind you, as we saw in the first NBS breakfast, NBS are hopeful solutions to develop cities while bringing responses to the challenges they met: climate change, biodiversity loss, soil and water management, health and security, and so on. To address those challenges, urban nature has to be enhanced and urban practices changed, adapted. One of NBS requirements is to bring benefits for biodiversity, as it is necessary to create or restore functional ecosystems that will bring, thanks to ecosystem services, co-benefits for human, like air and water purification, lower the temperatures, urban space resilience, recreation spaces, etc. To ensure these benefits and co-benefits, city developers need to check the efficiency and the relevancy of their new practices to check the performance of the implemented NBS. Non-adapted developments could indeed bring limited benefits or even negative impacts. It is quite easy to imagine the difference between a simple sedum roof or a roof with diversified vegetation that is obtained from a real work on plant species choice. But planning, developing, and management generally require sophisticated choices. So as an urban planner or a developer, how can you ensure your scenario is relevant? How to be sure of the NBS positive impacts? Well, to check this, assessment is a good lever. It enables to quantify the expected benefits and impacts of your projects. It will help you to adjust your practices if necessary, and it will also give you concrete elements to convince policymakers and citizens of the interest of your nature project. To assess, it is yet essential to have a good knowledge of your territory and your local constraints and to define your objectives precisely. So assessment results from an analysis of the initial situation and an understanding of the local context in which a project will take place. So diagnostic is therefore a crucial step. Lots of input data can be needed to collect for diagnostic needs. Databases and maps about meteorological data, biodiversity inventories, soil use, information about green spaces, trees network, hydrographic network, existing management practices, soil properties, and so on. We are aware that territory data access is unequal on geographic and scientific level because depending on territories, disparities can be met, because everyone doesn't have the same access to measurements and updating of geographical, ecological, climate data, etc. This often requires the help of experts with quite heavy collecting processes, which makes it difficult for some municipalities to measure a service with simplicity. However, you may today benefit from new tools and methods developments for collecting data, such as high-resolution satellite imagery or aerial inspection by drones that are often tested in real pilot sites. Mapping innovative services like TerraMap or Colory have been used on Nature for Cities pilot sites in the project. You can find information about these tools on the platform. Then it is important to ask you again why you need to assess. The purpose of the assessment has to be clear because it will determine the objective of your evaluation process. Maybe because of lack of data, we often tend to evaluate subjective things such as landscape aesthetic criteria. But essential ecosystem services functions are generally poorly taken into account, like filtration, carbon storage, pollution, or urban heat island regulation, health supports, and so on. To better quantify these functions, more and more assessment indicators are developed. An indicator is above all a communication tool that translates and quantifies observed phenomena. It is important to select relevant, concrete, and realistic indicators regarding your farewell objectives. Which challenge do I want to address? What are my local constraints are the questions. For example, to reduce urban heat island effects, some models have shown that a district refurbishment in an urban park could lower the temperatures from 2.5 to 4 degrees. But this effect would be very local with a radius of about 100 meters. So the idea behind this example is to show that the park can be an adapted solution or not, depending on the needs. Am I trying to address a strong local vulnerabilities with the proximity of a school or seniors, for example, in which case the park can be a good answer? Or does the low radius of the cooling effect doesn't address my challenge? The use of indicators can help you to confirm or adjust scenarios to find an optimum answer. And finally, the assessment will be as interesting as it will be taken into account early. It is not an external step. This reflection must be integrated in early planning processes to facilitate adjustments. Models and simulations can, for example, help you to assess in early stages. On the same idea, after NBS implementation, it is important to establish monitoring of ecosystem services provided by NBS all along their lifetime. This assessment can help you to adjust management practices. So, assessment associates knowledge and a strong argument to change practices and convince all stakeholders. It is a tool for more efficient urban policies towards nature. Now, in Nature for Cities, that's what we've done. So to lower the difficulties often met by municipalities to collect indicators, help can come from the development of new tools linked to NBS. And for example, Nature for Cities aims at giving access to an online simplified urban NBS assessment platform in which you could create NBS project scenarios in your city and assess them. More precisely, Nature for Cities partners work about assessment, consisting in selecting a panel of indicators to measure NBS performance on each defined urban challenge, with a reflection on indicators' choice criteria. The indicators had to be easy, credible, accepted, robust, give the possibility to measure challenges at different scale, and so on. The project partners have also tested existing assessment models linked to the selected indicators. Those tools, normally for more experts, have been integrated in a simplified toolbox to give access to scientists' methods to a wider audience. So the platform is currently tested on our pilot cities. For example, Alcalá de Henares in Spain needs to assess what can be done to address biodiversity loss in some spaces. For future developments, the measure of biotope area factor that describes the proportion of surfaces available for biodiversity regarding the total surface of a site. It can guide the city to find accessible sites for NBS implementation. In terms of management, the Sustainable Practices Indicator analyzes management practices on a given site about soil, water, biodiversity, resources, which can help the city to adjust its practices in order to maintain ecological processes on the assessed site. A tool, GreenPass, has been developed within Nature for Cities to guide planning and assessment regarding climate change. So in the pilot city of Szeged, which works on urban heat islands reduction, this tool is being tested to estimate several scenarios' impacts on urban microclimate to choose the best compromise, principally regarding thermal comfort. So I will not further detail the indicators because there are a lot. But this simplified assessment toolbox first objective is to give you, urban planners and developers, in the first steps of your project, a direction to help you to place your action. However, it will not replace experts' work or real studies because, for example, it cannot always bring very local results because of the unequal access to input data from a region to another. But the platform objective is precisely to help you to use the right skills depending on your needs to favor a complementary scientist-developer approach. So to help you to work with ecologists, soil specialists, climate specialists, and so on. So NBS are generally thought in a more global approach of city development impact reduction in a context in which urban population increase that brings the necessity to build new accommodation and infrastructures. Environmental assessment can also consist in measuring the negative environmental impacts of these developments and the linked NBS, from their design to their end of life. Measuring these impacts can help you to ensure the relevancy of solutions used to limit them. For example, life cycle assessment, which will be integrated to the Nature for Cities platform, is a relevant method to measure these impacts. That is what Pyrène is going to present you. And to finish, it seemed important to show you how a municipality can appropriate these assessment issues at different scales. And Vera will talk about Vienna's strategies about urban heat islands and green walls and roofs project that were facilitated thanks to technical guides, assessments, indicators, and so on.
Thank you, Marion, for this very interesting presentation. So, Pyrène, we let you present life cycle analysis.
Thank you, Mathilde. Hello, everybody. I'm very pleased to be here today to speak about the environmental assessment of NBS. First, some elements of context to understand why we should conduct an environmental assessment. As you know, the quality of life in most cities in the world is threatened by increasing pollution levels, urban heat islands, flooding, and extreme events which are related to climate change. And these threats are very detrimental to human health and ecosystems. In parallel, in the last decades, humans have modified and altered very heavily all ecosystems, and this has resulted in about 60% of the evaluated ecosystem services that have been degraded in only 50 years. In addition, more than half of the world population is currently living in urban areas, and this share is expected to reach 2/3 by 250. So, as you can see, there is urgent need to find solutions to tackle these issues, and this is why revegetation of cities is at the heart of current politics and programs Maybe you heard in France about the last municipal elections, but there was a huge green wave, we call it this way. So revegetation is really very important for municipalities. The NBS concept has been also identified by companies, private companies, as a strategic frame to reach their carbon neutral objectives, to meet Paris climate goal. And consequently, many NBS projects are flowering all around the world, and particularly in urban areas. But have you ever wondered which impacts do these systems have on the environment? Before to know how we can evaluate these impacts, I propose you to discuss why we should calculate them. The first reason why we should calculate these impacts is to compare different systems and to show the interest of NBS compared to classic gray solutions, or to compare several NBS options between them. So here it's an illustration of how green solutions can have a smaller impact than gray solutions, for example. In this way, private and public planners can adjust their projects to better meet the environmental objectives they want to reach, for example, about the carbon footprint of their projects. They can also have concrete figures to defend the implementation of NBS if needed, to see the advantage of NBS instead of classical, conventional and polluting solutions. As examples, you can see here, for two NBS systems, rain garden and green roofs, we can have comparisons between green and gray solutions, and you can see that impacts of green solutions are generally much more smaller than impacts of gray solutions. The second reason why we should conduct an environmental assessment is for eco-design purpose. Here we want to identify the hotspots, which are the main contributors to the impacts, in order to know where to put the efforts to improve the design of the NBS to make it more environmental friendly. As Lord Colvin said, if you cannot measure it, you cannot improve it. So we need to have this information to know where we can have levers for improvement. The results of these assessments are generally presented in stocked bar charts. In the examples you can see here, we can really spot the steps of the system that contribute more to the impact, and you can improve them. For example, for the green roof, we can change the materials, for example, for the drainage layer, or we can find other levers of improvement. Yes, and the last reason why we should conduct an environmental assessment is to ensure an holistic assessment. It means that more often when we talk about NBS, we try to evaluate the benefits that the ecosystem benefits that the NBS can provide, for example, water regulation or climate regulation. And we focus on this utilitarian aspect of NBS. But the NBS has also impacts on a lot more of several issues. And it's interesting to weight the urban benefits against the environmental burdens. So in a study of Wang in 2013, the objective of this study using LCA was to see if the water quality and ecosystem benefits provided by the NBS was equivalent or better of the impacts of the NBS. In other words, if the impact of the NBS can be offset at the benefits that it brings to the people. To answer this question properly, I mean, is the impact higher or smaller than the benefits? We need a life cycle approach. Why? Because it's necessary to take into account not only the impacts occurring during the use stage, which is the usual focus, where we really assess the urban and socioeconomic benefits from NBS, but also all the other life cycle stages of the system. So we have to take into account the production stage, the implementation stage, and the end of life stage, where the NBS has also impacts on the environment. And the appropriate tool to do that is what Marion presented before, the life cycle assessment, or LCA. So in a few words, what is life cycle assessment? This method is a mature, robust, and internationally standardized method, which is globally applied, and it has three main characteristics. The first one is, as I previously showed, it takes into account the entire life cycle of the system, from cradle to grave. So this provides, as I was saying, a holistic view of your system. The second characteristic of LCA is that it's a method which is multi-criteria. It means it covers a large range of environmental issues, for example, climate change, eutrophication, acidification, resource depletion, or toxicity. And the last characteristic is that the impacts are expressed per what we call a functional unit. It means this functional unit describes the function or the service that is provided by the system. To illustrate this functional unit, let's take an example. So here, for a green wall, we can use the functional unit of 1 square meter of green wall. It means that every environmental impact, for example, climate change, will be expressed as impact per square meter of green wall and per year. So all the inputs and output flows of the system for the whole life cycle will be gathered and modeled, but then the impacts are divided by the surface area of the green wall and its lifetime. And in this way, we can compare several green walls between them with different surface areas and different lifetimes. Another example, for example, for a green space, it's the same. We can have a functional unit of 1 square meter, and we will gather all the inputs for the whole life cycle and divide it by the surface area of the green space and its lifetime. And then, in this way, you can compare several green space systems with different surface areas and lifetimes. So in this way, we can have a common unit to compare all the systems. Regarding the boundaries of the system now, here is an example for the green wall. So we have to take into account all the inputs and the outputs of the system. So for the production stage, we will look at raw material extraction and transport, production processes, and transportation to the implementation site. We will look at the mounting system, the planting system, the irrigation system, the seeds that you will put in the wall. We have also the substrate to take into account, the carbon storage during the use stage. And for the use stage, we will also have irrigation, fertilizer, and more seeds. So during the use stage, you will have all these elements, but you will also have into account the emissions that are emitted in the environment during the lifetime of the wall. And finally, we will look at the end of life of the system, which is the recycling, the incineration, or the landfill of the raw materials. And for the example of the green wall, we will also have the treatment of bio-waste. Again, the second example on the green space, on the same principle that for the green wall, you will have the production stage with the plants, different type of plants, trees, shrubs, or grass seeds, for example. In the case of bird-friendly garden, you can have also some accessories like nests, waterers or feeders. You will have the irrigation system, the structure of the soil and the compost, the irrigation system, the mowing, and the carbon storage, and compost and seeds. Now we can use once you have described your system like we did, you have to build the inventory of inputs of outputs, and this is a complex step and often very time-consuming step, and so you need to rely on tools. You can either use complex LCA tools, which are very sophisticated LCA software, which require deep LCA expert knowledge and a large amount of time. You can also use simplified LCA tools, which are with a pre-configured modeling, which it's more accessible and which require a reduced LCA expert knowledge and provides faster analysis. So as Marion presented, we have developed in the Nature for Cities project a simplified toolbox, and among the tools developed in the toolbox, there is the environmental assessment tool, which is composed of two different parts: material flow analysis and life cycle assessment. Material flow analysis is the aggregation of different material and energy flows on the life cycle of the system also. And life cycle assessment goes further and calculate the impacts associated with all these flows. So here, to take an example, I will not enter too much into detail about the inputs that we need, but I wanted still to show you what kind of data is needed to conduct an LCA. So if I go back to the description of the green wall system that I showed previously in a circle, now it's more linear, but you have still the production stage, implementation stage, the use stage, and the end of life stage. You can see there are a lot of different inputs that are needed to calculate the inventory of the system. So in the simplified LCA tool, what we did is that we targeted the inputs which have the biggest influence on the results. And we here, so in orange, and this is the input that we are going to ask to the user of the tool. It means that all the other inputs we know that they have a small influence on the results. So we provided default values for these inputs. So here, for example, you have 11 parameters for the production stage. So mainly weight, for example, weight of the aluminium in the mounting system or steel in the planting system. You have also weight for compost or sand and brick, which makes the substrate. You also have to give the volume of water for irrigation and the weight of fertilizer during the use stage. And of course, you have to provide the green area and the green lifetime. I forgot to say that the user will give his specific values for these parameters, but just in case, we provided also default values in case the user doesn't know which value to put in the tool. So now that the system has been modeled, the important question is what time of result we can obtain with LCA. So there are two types of indicators in LCA. We call them the midpoint indicators, and these indicators are located in the beginning of the cause chain effect of impacts. It means that it looks at a difference in the environment, a change in the environment, for example, an increase of the radiative forcing in the atmosphere caused by a human intervention. In the example of the radiative forcing, it's an emission of carbon dioxide. And these midpoint indicators can be climate change, ozone depletion, human toxicity, acidification, resource depletion, and so on. These indicators have less uncertainties because they are at the beginning of the cause chain effect, but they are not always easy to understand and to explain to deciders, to public deciders, for example. So we have also a second type of indicators, which are the endpoint indicators. These indicators directly assess a damage to 3 areas of protection, which are human health, ecosystems, and resources. And these endpoint indicators have, as you can imagine, a bit bigger uncertainties because they have to make more assumptions to obtain damages, direct damages to this to human health or ecosystems, but they are often easier to use and to communicate with the results. So here is an example that the results we can obtain with the simplified LCA tool. So it's the midpoint indicators of a bird-friendly garden in Hungary. And as I was saying, the results are presented in stocked bar charts. And we can see that every bar is an impact, and between and on the bar you have different contributors to the impact. And here the bigger contributors to the overall impacts are the soil preparation in brown, the emissions in the environment after compost spreading in purple, and also biowaste treatment in peacock blue. So you can also note that we can have negative values, for example, for climate change. And these negative values are due to the fact that NBS systems are often composed by plants, which capture carbon dioxide through photosynthesis and then have a negative impact on climate change. Another example of results we can obtain with LCA are here endpoint indicators of a green wall in Austria. And here you can see that most of the impacts come from the production step of the green wall, mainly because of the extraction and the manufacturing of the aluminium that is used for the planting system in green, blue-green, and for the mounting system in yellow. You can also see that the waste treatment of the aluminium, even if it is recycled, has a lot of impact on the end-of-life stage of the green wall. You also have different impacts due to water consumption and irrigation during the use stage, and the use of fertilizers. Well, to go further, I strongly encourage you to test the Nature for Cities platform if you have an NBS project, and if you want to know more about the environmental assessment tool, please contact me.
Thanks a lot, Pyrène. So we had 2 questions from Jordan in the chat. So the first one was he had the feeling that NBS seemed to be a concept driven more by municipalities than companies, and he was asking us if it was true, or was there some solutions reserved to collectivities and others dedicated to companies? Are there different approaches? So we already answered in the chat, but I'm going to share our answer to everyone for everyone to have the information. So in fact, the concept is useful to a wide range of stakeholders. If we focus a lot on municipalities, it's because regarding the assessments, we think that the municipalities and the city planners are the ones that are going to be the sponsors of the assessment, but then the private sector can propose assessment services or NBS provider can also convince a client that an NBS is better than gray solution with using assessment, and so having some arguments to explain that this solution is more interesting with benefits and co-benefits than another solution. And I shared in the chat a link because the H2020 project Connecting Nature created a platform dedicated to enterprises, specifically dedicated to enterprises, called Nature-Based Enterprise. So if you are a company, it can be really useful for you to join naturebasedenterprise.eu.
I just wanted to add that LCA, the tool, was initially developed for companies. So it's really a product tool, and the tricky part is to adapt it to NBS systems. So we are really here more coming from the industrial world, and to applying it to the natural world, I can say. So this implies a lot of methodological challenges, and it's very interesting, I think.
Thank you, Pyrène, for these precisions. So we have a second question, which is there a source website gathering LCA results of NBS projects? So maybe, Pyrène, you can explain how the LCA results are going to be displayed on the Nature for Cities platform.
There is, to my knowledge, there is no source or website gathering LCA results of NBS. But during the NBS project, we made a huge state-of-the-art of all LCA studies applied to NBS. And we are currently writing a publication on this work that will come out soon. So it will be soon available, along with the deliverable that explains this work. So if you want, you can write to me, and I will send you the publication as soon as it is available. And this publication will detail all the work of LCA applied on NBS so far.
Thank you, Pyrène. So now we are going to jump into a practical example. We already had two practical examples presented by Pyrène, a green wall assessment and a park assessment. And we wanted to show you too that the environmental assessment can be displayed at a wider scale. So if you remember right, the green wall that was presented by Pyrène was developed in Vienna. And it appeared that Vera is living in Vienna and knows very well the strategic documents about heat island in Vienna that can help us see how the environmental assessment can be led at a city level. So Vera, we invite you to present this very interesting document.
Yes, hello and good morning also from my side. I hope you can hear me and you can see my presentation well. Good morning from Vienna, actually. That is slowly coming back to life after the difficult last days. You may have followed the terrorist attacks. My name is Vera Enzi. I'm from GrünStattGrau, which is the Austrian Innovation Laboratory for Greening Cities. Also, maybe just quickly answering your question, Jordan, we are a large-scale network of, at the moment, nearly 400 participants that are really working on deploying green infrastructure and NBS across our cities in Austria. And I have to say that over 70% of our network partners are actually enterprises and companies. So from my personal view, I can see a very big interest here on that side. Yeah, but just that much from my side. Today I have the pleasure to introduce the Urban Heat Island Strategy Plan of the City of Vienna to you. This short input is about the background, the strategical approach, and also the surrounding framework. And before I start, I have to give some big thanks to the City of Vienna itself, the Department of Environment, and a very special person who is working there, my colleague, Mr. Jürgen Preis, who is also a landscape planner like myself and who was mainly responsible for this urban heat island strategy I'm going to talk about in the next few minutes. So on the right side, you can see the approach already, and I'm going to jump into the topic right now. So what you can see here is actually a thermal image of the city of Vienna, and this was actually the starting point for the strategy itself, so the raison d'être, as you would say. What you can also see now in the picture here is the average hourly temperature distribution between the very urban inner city center and also the rural area surrounding Vienna. And you can already see that during the day, only in air temperature already there is a big difference of 3 degrees currently, and in the night it's even getting much more, so it goes up to 5 degrees Celsius. This is of course a development that you can find in a lot of cities actually across Europe. You can see a scenario for the urban heat island effect on the left side. So the upper picture, which is slightly still in blue, is the period from 1971 to 2000. And the second one in the lower part is actually the reference scenario from 2071 to 2100. And you can already see very easily that Vienna is awaiting a very big change in case nothing is changing due to climate change. And on the right side, on the upper part, you can see a picture that actually already illustrates the change in the energy supply that will be needed for heating and cooling. And the result is quite easily to be explained. So on the left side, Vienna is facing doubling heat days in the coming 100 years. And on the right side, the cooling load is going to triple already in the coming 50 years. And this was one of the main basic reasons why the city of Vienna decided to get active. So the strategy was developed in a cross-border EU project in 2010 to 2014. The strategy itself consists of a framework program that has a lot of different elements, like shown on the left side in the graphic. So centralized, there is a very strong implementation program accompanied by strategic instruments, technical measures, procedures, monitoring, evaluation, information, PR work, and of course a legal framework. Something which was of course central as well, that the whole process needed to be cross-sectoral, interdisciplinary, integrative, and an interactive, let's say, living process. So what came out of this? This is on the left side here, the official public document, the strategy. It's also translated in English, and it can be downloaded very easily from the page of the government. And it contains 37 strategic and technical measures. So strategic measures are, for example, to enhance the ventilation and enhance the connectivity of green space in the city, adjustment of the town structure itself and the shapes against overheating, the brightening, so changing the albedo and the color of surfaces such as pavements and streets and buildings, an increased volume of vegetation across the whole cities and streets and open spaces, the greening and cooling of buildings themselves, not only in new city quarters, but also, of course, the existing building stock. Increasing the water capacity in the city would be as well a strategic measure, and also shading of spaces and streets, for example, via the building structure itself, or for example, integrating as well a lot of trees for shading purpose. And on the right side, you can see already some of the technical different measures listed. I'm going to explain in detail how actually this document works and how they look like. So if we're looking at the measures for buildings in detail, the strategy plan contains a lot of different measures on the left side, also intensive and extensive green roofs and vertical greening of buildings. Other technical measures would be, for example, also implementing shading devices on buildings, the water cooling and active and passive cooling of buildings, for example, through ventilation, long distance cooling, component activation, insulation, and so on. And looking a little bit more into detail On the measures for greening and cooling of buildings, we can already see 4 different technical measures on the left side. Oh, I'm sorry, it's jumping a bit. So the first one, green roof, second one, vertical green, third one, active passive cooling of buildings, and the last one, the water cooling. And I'm going to jump into detail of the first 2 measures in the next few slides. So looking more deeply into the different technical solutions proposed, they are rated, basically using a spiderweb matrix that builds on the 3 parameters of climate, biodiversity, quality of life, and economy. And on this picture, for example, you can already see the first comparison between extensive green roofs and intensive green roofs. And this basically rating of the different technical measures is further on then used to be implemented into the different scales of operative actions, like I'm going to explain in the next 2 slides. That would be the other example for green walls, for example. So on the left side, this is a facade greening with climbing plants without irrigation, and the more blue color spiderweb graph is already a living wall system, like illustrated in the picture on the right side. Talking about the urban heat island adaptation and implementation process, the presented technical and strategical measures are used according to their rating and their benefits, and applied across the different levels of controls and scales. So what you can see here is the different planning levels and scales on the right side. So from the strategic urban development, which also contains then in the next step master plans, design concept, land use development plans, green and open space planning, and the building plan design, and the different kinds of scales connected to actually these strategical planning approaches. So from citywide to really very plot specific. Yes, as the next governmental example, so also in 2015, there was a governmental resolution put in place that actually fosters the urban heat island strategy and all the measures it proposes. So there is a political order since 2015 that the creation of air conditioning systems across the city in the densely built urban areas has to be done through vertical green areas and roof greening. And the governmental resolution also talks about the promising measures from the urban heat island strategy plan that have to be implemented and to prevent the overheating of the city. Another example for another control level, so this is the City Development Plan 2025 step. It also contains a lot of urban heat island key objectives. For example, it says greening city instead of air conditioning, technical air conditioning of buildings. And it talks about as well improving the comfort of public spaces by protecting them against summer overheating, for example, by adequate greening, shading, and ventilation, and the adequate choice of materials. And another level here would be the legislative framework. So the Vienna building regulation, also as a result of the urban heat island strategy plan, includes provisions for the construction of roofs and buildings, for example, in particular green roofs, and the land use and zoning plan, not only for new city quarters, but as well for refurbishment and renovation activities, concludes very various and different settings. So there would be 2 examples. For example, all roofs that are over than more than 12 square meters of size and have to be designed as flat roofs and need to be greened according to the state of the art, which would be the Austrian green roof standard listed here on the right side. And also 1/5 of the facade in the new developments at the moment needs to be greened as well, according to the state of the art. And yeah, last but not least, a final example on the monitoring and the information side. So all of the information we have seen already now is also incorporated in the city's digital cadastre system. So the cadastre system of Vienna includes a very detailed stock cadastre about the green roofs that are implemented already and the green facades. And it also points out the potentials for new green roofs and green facades in, of course, the new city quarters, but as well, of course, the existing city quarters. And something which is, I think, also exceptional, the cadastre as well includes the different levels of implementation for solar energy production units, for example, of course, in combination with green roofs, for example, too. And on the right side, some technical information examples. So there is a guideline for green walls since 2019. The green roof guideline is being done new this year. It's going to be soon published, I think at the end of November. And so does the solar and green infrastructure guideline, which is also being republished in this year of 2020 now. Yeah, finally, the big picture. Where does the urban heat island strategy come from and where does it go to? So the city of Vienna has also a citywide project called INCA. INCA translates into infrastructural adaptation to climate change. And it is actually a citywide program that ensures the implementation of the Sustainable Development Goals of the United Nations. So the program has many different levels, from public procurement, technical solution, innovation, and also test projects, climate adapted tenders, competition, and many more. And on the other hand, also it includes not only mobility or energy, the productive city, for example, as well, social and nature-based solutions and green infrastructure, which is, yeah, let's say, I think a very future-leading development here that can be, yeah, pointed out. So thanks for your attention. I hope I give an interesting input to you, and I'm happy for some discussions now.
Thank you very much, Vera. So in the chat, we had Stephanie Decker asking us if we had a link to the guide. So I found it and shared it on the chat. And I shared two other links because the city of Vienna is an example about one challenge, which is urban heat islands. But there are other cities working on such diagnostics and plans. It was just to show you that that can be made on other challenges. For example, the city of Berlin worked on the soils, and just like Vienna did for the potential for green roofs and walls, they did a diagnostic for the unsealing of some areas that could be restored and the soil could be unsealed again. And Vera, are the technical documents available online too, or not?
Both of them are also online, but the issue is at the moment that they are not translated into English. So all the technical documents related to the roofs, the walls, also the solar one are only in German at the very moment.
And yes, I had one little question for Pyrène. If you had a little piece of advice to give to municipalities and companies, what advice would you give them to help them use the LCA method?
Yes, good question. I think I will advise municipalities to seek for support to conduct the LCA of their systems, because LCAs can be quite complex. But what I will also advise is that they try to internalize the LCA and maybe develop a special tool for them to manage their projects. It's what we did, for example, here in Bordeaux to a public planner which wanted to have the environmental impacts associated to each new operation that they develop. So we developed a special tool for them to monitor the environmental impacts of the operations, so they could play with the tool and improve the tool, not the tool, but the operations to decrease their environmental impact. So I think it's interesting to not only do one LCA that everybody forgets but really have something interactive and useful for municipalities.
And maybe Vera, do you want to answer this question for the links between companies and the city in Vienna, maybe? How they can work together?
Yes, actually, our network also plays a big role in that, because the innovation laboratory is like a nationwide approach for nature-based solutions and green infrastructure deployment across Austria. So the city of Vienna is, of course, one of our central cooperation partners, like all the other cities in Austria as well. So at the moment, we have approximately, I think 70 city partnerships. And of course, companies and enterprises in our network are trying to aid and help on the regional scopes of their activities. So planners, for example, but also system providers, landscape contractors, companies who are specialized on, for example, also maintenance and care. So I think there is a very fruitful and direct cooperation in Austria in between the cities and the regional economy, which is also, of course, a political issue and goal to work closely together on the one hand to ensure prosperity and of course on the other hand also jobs and well-being for people that can actually live and work basically on a very, let's say, this very small regional scope.
Okay, thank you. So I think we are going to close this NBS breakfast because it's past 10 a.m. So thank you all for attending this second breakfast. Do not hesitate to register for the next one. And the replays are available on the Nature for Cities website. So we really warmly thank Vera and Pyrène for joining today and for their very interesting presentations. And so we wish you a good day.